Hello everyone, my name is Tim Cridland. I'm a solution consultant and also product manager for Arcserve. The first half of this presentation is a personal reflection from me on my earlier time in the industry when I was an infrastructure manager and backups architect for the University of Queensland here in Brisbane. These are my personal notes. So not necessarily a reflection of either Arcserve or the University of Queensland and their view of how things go, but also really just in terms of those lessons learned from an actual event, that we're all actually experiencing day to day at the moment. Again, with that list that Amanda was talking about, COVID on top of floods, on top of flu pandemics, on top of staff shortages, on top of infrastructure challenges. As a presentation structure, just so you all know, I've got a few slides discussing applications and backups architectures and best practices, and then some RTO and RPO concepts that you'll all be quite familiar with, so we'll speed through that a bit. And then a real-world example of how that's actually worked for me in the past, and then some more modern technology concepts that allow us to improve things in the future. So this, for the sample architecture that we have. So this is a stretch cluster architecture at a very high level with not much label. But if we look at that, what we have is between two different physical data centers, typically on a campus, so dealing a lot with campus networks, which could be industry or education, or even large business. As a core of that architecture, we have synchronous storage. So this can be built on asynchronous storage, slightly different from an architecture point of view, but generally a very similar outcome. What you end up with is every single write of data that is going to one of those pieces of storage hits the other storage layer as well, hits the storage in your other data center. As a requirement for that sort of architecture to work, that allows your application to float between data centers because it doesn't know where it is. The storage is pretending like mad that it is just one storage array, and it's actually just two storage arrays pretending to be the same. So concepts you might be familiar with like Metro cluster from NetApp, for example. For that architecture to work, for that VM or for that application layer to work, it has to rely on the fact that the server hardware is exactly the same in both data centers. Obviously, otherwise the application, it shuts down, it turns on, it says, where's my hardware gone? I've got a completely new motherboard set, I've got a new CPU. Everything slows down for a minute while it does discovery, and then you float back and it does the same sort of process. So there's a requirement on the stack for everything to be exactly the same, and this is important for later in the talk. Typically for over the last 20 years, so I've been in the backups industry in particular since 2001, and you see a lot of campus networks where you have something like site A is backed up to site B, and site B is backed up to site A, and we have a lot of remote sites or satellite sites, and for the most part they're just protected somewhere to head office so that we have somewhere that we can shift that data to. Pretty standard. And what it also does is it roughly complies with what we have as our architecture standards here. Actually, hold on. Before I get into that, what's interesting though is as these architectures grow and shrink over time, right, you'll end up with a bit of a mismatch. You might have 80% of your backup storages in one side, or you might have, for example, 10 tape drives in your primary data center because that's where you prefer to do most of your tape swapping, because that's where your admins are that do that tape swapping on a regular basis and put them in a fire-resistant safe or send them off to Iron Mountain or to recall. So there's a lot of pragmatic things that actually come in the day-to-day operations of this sort of thing that actually aren't really reflected in a high-level architecture diagram. But it always ends up being roughly A to B, B to A, everything else coming in. That roughly lines up with what it is that we use as our best practices today, right? So as a best practice today, we did have a lot throughout the industry. Again, over the last 20 years, we've had a lot of, okay, what's a rule of thumb for how it is that we deploy backups architectures? And generally a 3-2-1 policy is what we would describe. So 3 copies of data, including your primary. So you'd have primary and then a secondary copy and then a third copy on some sort of backups media. On at least 2 different types of media. So snapshots inside your storage array don't count, right? You've got 2 copies of data, but they're both on the same hardware platform that might fail. And at least 1 copy in a separate location physically. So again, just making sure that you're protecting against a physical issue with that data center in some way, and having at least 1 copy of your data at some point that we might at some point have to work with pretty aggressively to try and get back, but we know that we've always got a copy of data somewhere. What we have more recently as an industry and what we follow here at Arcserve is a 3211 rule of data architecture. And that's really just making sure that at least one of those copies is on something that is immutable or worm, right? Or write once, read many. There is a challenge with 321 where you can have the same Active Directory user have access to all 3 copies of that data in 2 different sites, including offsite. So you're not necessarily protected against ransomware unless you've actually ensured that you have at least 1 copy of all of your data that is immutable in some form or another. And that helps us to just provide that complete solution and provide that, again, high-level rule of thumb. So making sure that your backups architecture conforms to that, then for the most part, you're protected. Last concept slide, or second last concept slide. Typically when we talk about regular DR planning, we talk about, okay, we've got a recovery point objective. Again, for the most part, this audience being highly technical will be pretty familiar with these concepts. But your RPO is from your last backup to when you have your incident. So you never know when an incident is going to occur. Obviously, if you could change that, you would. But just making sure that you understand this is the data that you will lose because you're going back to your last backup. And your recovery time objective is exactly how long it takes to get that data back. If you're a bit more advanced, you've done some incident response planning beforehand, right? So before you have your last backup or before you have your incident, you've actually had some, either you've sat down, performed a paper workshop, or you've had a meeting with the business to talk about, okay, this is what would happen in the event of a disaster. Generally, that is a very technical process, right? It's run by your IT team. They might consult with the business. But for the most part, it's very tech-led. What is really interesting is when you look at that incident to recovery pipeline, the actual steps, it just seems like, okay, we've got an incident, we restore that data. But when we look at what is actually required for that process, there's a number of micro steps that are inside that. You're retrieving your data from offsite, so again from your Iron Mountain. You're building that backups and recovery environment. So if you've only got a copy of the data, but you don't have a backups environment anymore, you have to rebuild that, and that takes time. You have to restore that data to somewhere that hopefully you've procured, so you've got to buy your hardware. If you have that stretch cluster architecture, then you've had to rebuild that architecture. You may have had to rebuild your physical network access points, so doing the plumbing works, as we know, can take some time. You may have to restore that clustered data. You may have to remediate your disaster recovery site, depending on exactly what shape of disaster you've had. In the middle of all that, you are managing your staff workloads. You are training into monitoring your staff because typically you've only got 1 or 2 people looking after your backups. In the event of a disaster, suddenly you need 16 people engaged in that effort, so you need to be training them at the same time, and also making sure that they're not breaking things. You do need to continually communicate to your shareholders, and those stakeholders may be external and friendly, so they really want you to succeed. They may be external and other, so that's not necessarily unfriendly, but they're not interested in whether or not you're back, right? So say dealing with city council to try and get a permit to do a building, they don't care if you're in a disaster, right? They will take the time that they take. And then also you have to manage expectations and discovery of unknown unknowns that happen through that process. So if we look at that backups architecture again, what happened for me, so this was my backups architecture generally, and what happened for me is we had a fire that hit one of the UPSs in our primary data center. Right. Now you can see that there's not that much fire damage outside of the immediate scope of that UPS. So we can see that there's basically just a bit of smoke damage that's nearby, a bit of heat effect on the roof above, but for the most part, the room outside of that environment is largely unaffected. And that's because the fire services were there within 6 minutes of detection, right? It's amazing, cannot talk highly enough of them. What further happened to that though is that because it was an impact on the UPS, the rest of our mains power and the rest of our generator space and the rest of our air conditioners and our servers kept on running. And what that caused is a large amount of smoke damage. So even though it was only 6 minutes before fire services were on board and about 15 minutes before everything was out, our servers and our compute and our air conditioners had managed to pull through an awful lot of acrid smoke. Now that battery smoke, it's like a black particulate that is very plasticky. So you can't just wipe that off, right? It is a sticky substance, and it's also got a lot of chemicals in it, so you don't want to do it barehanded either. You want to be with gloves and in PPE when you're looking at that. And we had about 80 racks in that data center, and all 80 racks had some form of soot on them that required some remediation, so each of those racks being about 38 RU high, so a good couple of thousand devices. And if we look back above where the UPS was and where that heat damage was, we can see there's a small crack in the top left part of that tile there. And when we looked above that false ceiling, again, because this building was from the 1960s, there was asbestos in the pebblecrete. So in the ceiling treatment, there was some form of asbestos. So really the only way to clean this room was to remove absolutely everything, including the false ceiling and including the ceiling, right? So there's a cascading effect from a relatively small fire to having to remove 80 racks and all of their equipment and clean them in a very technical way, replacing fans and doing a fair bit of remediation. So as fast as we could possibly get, and could not possibly ask for a faster response. We say, okay, you were there in 6 minutes, could you be there in 5? It would not have made any difference after the incident of the batteries actually catching alight. And then, we had to get that data center back to more modern standards, right? So we took the advantage, we took the time to actually rebuild to a proper standard, drop cables, proper cable management, better lighting, so improving a lot of things that would not have been heard of in the 1980s when that building was first built. What that comes back to, so just keeping an eye on the time, because I can talk about this for about 6 hours if I'm let go. Okay, all right. What that does for our timeline, so if we go from that first circle on the very far left, right, we have, okay, so that's the last backup, and then we have the incident at that second circle, right? So when we talk about our timeline of actual response, what we have here is we have, restoring those services. Now, we were back up and running in about 6 hours in terms of failed over to the second data center. Most of that was just plumbing, so most of that was just rerouting networks. So again, you lose some physical capacity. There's some things that you've kind of planned for before, but it's 3 a.m. on a Sunday, so it takes a bit for everyone to actually get everything failed over. But by Sunday afternoon, we're back. Then for those immediate services, we have, I've got, just to rattle off some of the steps inside here, we've got all of the front-end services resumed. So the organisation is actually, websites are up, emails are being responded to, people can actually perform their functions. Then we have procuring some replacements, we've got remediate some hardware, stealing some data center capacity, so fortunately we had some that we can actually start deploying some server hardware back to, rebuilding some architecture, building some temporary redundancy, and that's important as well. So in the end, after a disaster like that, you end up in a temporary space where you've got a primary and a new secondary, and that all has to be undone at the end as well, right? So you can say, okay, well, in the event that I have a failure here, I'm going to be failing over to the cloud. And you say, okay, well, that's great, I'm failing over to the cloud. When I have everything rebuilt, then I have to bring that data back again. So everything that you do in this immediate after the disaster stage has to be undone at some point because you don't have time to do it properly, right? You're just doing it. And then you have a process where, say, after about a week, the business has started to relax a little, and after about 3 weeks when you have, so at about that midpoint, after about 3 weeks you have redundancy of your payroll databases and you have redundancy of all your secondary data sets as well, and all of your business as usual and common applications. So everything's actually back to a point where the business starts to relax a bit. But the job's not done, right? Because basically everything that you've done in that first 3-4 weeks has really been about temporary, get the job done, come back online. Then you have about a half a year where the business has relaxed a little and you're talking about just trying to rebuild that redundancy back to where it is that you were, right? So that best of breed A, B, active sort of data center, that takes a lot to actually reinitialize. So as a process, it's very powerful in terms of, yes, we were back up and running very quickly in terms of the data resiliency, but repriming that redundancy takes about half a year in my personal experience. And that includes building that, rebuilding that data center redundancy and all of your refurbish works as well. And then after that process and after all of your architecture is rebuilt, then there's a migration back, right? So there's a migration back, but also all of those processes that you put in place in a short period of time, you have to unwind all of those as well. And that can take about a year, right? By the time you've finished negotiating with your insurance broker to say, hey, this was an increased cost of business and we need it to be paid for this and we need to do that, that process itself can take a fair bit of time. So there's a very long tail for any of these significant disaster events. What happened for us was that we're in the middle of that sort of second phase. So after the architecture is all decided upon, but before they're all in place and before we have all of our redundancy, so we're still operating primarily out of the second data center. We had a new incident in the middle of that process, right? Now again, to the lovely Amanda's point earlier today, we're all experiencing this at the moment. We're all in the middle of staff shortages and we're having floods, right? We're all in the middle of a COVID pandemic and we're having hardware issues trying to actually find things. We're all dealing with multiple incidents at the same time. For me and for our particular large-scale incident where we had lost half of our capacity, we had the 2011 flood, right? So that red arrow there, that is pointing at our second data center. So we had failed over to that data center. It was only the secondary. So we weren't actually as concerned about the secondary data center because we always had the primary until it smoked, right? So we always had the secondary data center. So it was always the poor man's, which was fine, up until the point that the floodwaters got within about half a metre of flooding that second data centre. So at that point, where that red arrow is, it was running all of our payroll, it was running all of our email, it was running all of our communications. In particular, if you look at this photo, so about 20,000 out of the 50,000 students at UQ at that time were international. And so there was a large amount of concern, this being January, so this is when all of the intake finalisations are happening. So we have a challenge where we have a large number of international students that all they see of the news of Brisbane is this photo, right, because it was around the world, and might be saying, I don't know if I want to go to university there anymore. So we wanted to send, and we did. We had multiple, the communications kicked into overdrive. We were very reliant upon that email service. We sent out approximately 3 emails a day to our students to update them on where it is that we were, and also to say that those floods had mostly just impacted the outer lying parts of the campus, so sporting facilities, etc. But, and it was true, the education part of the business was largely unaffected. What was interesting after that is our groundskeepers kicked into overdrive and they had it completely refurbed by the time university started about 2 weeks later, which again was a massive effort. So we had a lot of quite stressful moments. The good thing about a flood, as you all know, is that you have that tide process, right? So you have that peak and then another trough and then another peak about 12 hours later. So you've got about 12 hours notice between when it is, okay, so my current peak is here, I've still got about 55 centimetres to go. Up the river, the next peak is only 5 centimetres higher than that, so I know that I'm actually going to be okay. So we know that we had about 12 hours notice, but we had a lot of immediate planning to say, okay, well, which staff are nearby enough to be able to get to the data centre, because a lot of roads are cut, and what is it we would be asking them to do? So again, very hurried training and very hurried understanding of, okay, these are the servers that I need you to take photos of everything before you pull them out. Fortunately, we didn't actually get to that. But what it did mean is that we were running yet another incident process in the middle of our incident process. Now again, because it didn't actually get to the point of hitting that data centre, we were quite fortunate that we didn't have that long tail of remediation. We did have a tail of remediation in terms of having to bring back a lot of comms. We had a lot of networking that went down, but again, that was pretty direct and pretty straightforward. What I took away from that, so being aware that I've only got about 10 minutes left, Some points that I actually want to highlight here, and I'll be down on the booth down in the corner here for the rest of the day, so happy to discuss this at length. Partner for scale. So one of the key issues that we had was, again, we only had about 2 or 3 people that knew what the backups interface looked like before the incident, right? So being able to draw upon extra staff would have been invaluable. So we did not have a technical partner ecosystem at that point, but that's one of those things that I have always done since then as an IT manager, is always making sure that you've got at least one partner or someone with extra resources that you can draw upon in the event that you have a disaster, because you don't have time to train people. Right. Maintaining pragmatism. There will be people that will lose their chips, quite frankly, right? So there are some people that are perfectly fine engineers and perfectly fine technical people and perfectly fine staff, but really do not know how to deal with a disaster and the stress of a disaster. And that's fine. That's not a personal failing. It's just a experience and exposure point of view. So really just making sure that you're not putting too much pressure on any individual, and also maintaining proper health and safety standards and ensuring that they are not overwhelmed. Know your insurer. So for that long tail, and this is, I think, particularly interesting for the world of cyber insurance that we live in now. One second. Prior to this, again, that DR planning was a very technical exposure, right? So we were all about, okay, how do we fix this server? How do we fix this service? We had absolutely no understanding of all the contracts that we had and all of the different insurance premiums that we had. Again, and that actually leads into keep it simple, right? So we had, being a university, we had a bit of a rainbow data center. We had so many different vendors. I think we had, at one count, approximately 160 different hardware contracts. You know those EULAs that you click through when you buy some hardware and you just say, oh, yes, I accept. And often they'll actually have terms and conditions on right to repair, right? So we had about 160 different contracts that we had to work through with our insurer because that was what we had accepted as part of that purchase. So we really freshened out our procurement processes, and really, if you're driving that through a partner, instead of actually just doing a lot of individual direct contracts, you can have a lot more control. So that paperwork counts when you're actually, you think that a disaster is very physical and you think it's a lot of physical works and actually just remediating hardware, but it's an awful lot of paperwork as well. And also 3211. So, we changed our architecture a bit in terms of exactly how it is that we architected things, and I've got a slide on the end of that. And now to the sponsored part of my talk, right? So preparing for a speedy recovery with Arcserve, right? So looking at the different types of architecture that we would apply and the different types of technical tools that we can apply nowadays. So Arcserve, we have been around for 39 years. We have not been in Australia for much of the last 5 years. Right. So as a worldwide player, Arcserve has a lot of strength in financial services and DR as a service. And we are really just coming back to the market here in a much larger way. We have, out of that 39 years, we have a large number of tools and products and also plugins and experience. So, SQL, Exchange, Oracle, SAP plugins. And we can apply our, again, 3211 architecture so that we know, keep an idea at the time. We can apply a 3211 architecture across all of the different types of architecture that we apply. So we use those, that quite extensive list of tools and programs that we have access to, and we can apply this to complex campuses and also to simple sort of environments as well. So anything from small and medium business all the way through to casinos, universities, full enterprise environments. Some of the technology that we deployed to that, at its core, we do a block level increment forever that is also compressed and deduplicated, so keeping those backups as thin as possible. That combined with our technology on global source side deduplication, so we have a hashing process to make sure that we are only picking up those sectors of data or those blocks of data that are not already existing in our backups database. So those two technologies combined allow us to ensure that our data stream is the thinnest possible, which allows us a lot of flexibility when we're talking about those campus networks. right? So when we're talking about those campus environments and we wanted to move A to B or to move the various remote sites in, we have a lot of flexibility in terms of how it is that we architect that, because we know that the data stream is going to be the thinnest possible. We also have two different types of virtual standby, so we can stand up a VM directly out of that backups instance. So again, speeding that time to recovery, getting those services back up and running. You know that you don't have to do a full restore process. We can actually just stand up a machine out of that. We also have virtual standby, which is a pre-recovery. So you can back up a machine, go through your whole backup chain, and we can pre-restore that to a virtual environment of some kind. And we can use those same technologies to do a short recovery process. So we can, as part of our plan or workflow, we can have a process where we stand up a machine, test it, make sure that it's logged in, make sure it's going to work, and then provide a check of consistency as opposed to your quarterly or 6 monthly or yearly compliance reporting and auditing that you have to do that takes a lot of time. Some architectures that we can deploy like that. So we can have there's a sample architecture of something I've anonymized of something I've worked on recently for a customer. I don't think that feedback's because of me, but anyway, I'll keep on going. All right. And we can then also have very interesting workflows from that, whilst keeping the pieces in place very simple. So we have a 7-step workflow to provide all of the compliance and to provide all of the testing. And ultimately, the architecture that we've provided here is 4 appliances, 2 of which are exactly the same. So in terms of an architecture, we can provide quite complex workflows to meet your compliance requirements and to meet that the business standards that you need and provide the workflow that runs with your business. So your business workflow is going to change over time, and we have the ability to construct interesting plans above our backups architecture. And this is what we did immediately at UQ, right? So this is what we did in response. Key thing here in terms of backups architectures, we had a third site that we could provide, that we could run all of our backups to for that immutable copy. So again, 3211 architecture, we have that immutable copy that's in a third data center. So still providing that HA between primary and secondary. So we still had 2 primary data centers that we were floating between. But really just making sure that our backups architecture did not get impacted in the event that either of those 2 would. Right? So this is typically just called a 3-sign architecture. It's my preferred go-to when we're talking about campuses now. And now, being aware that I should see the floor, if you have any questions, I'll be over in the corner at the Arcserve booth for the rest of the day. Again, I could talk about this at length. Thank you very much for your time, and thank you very much to BES Technology for the privilege and the opportunity of being here and talking today.